Okay, so I'd say we start the session. So welcome to the session on AI for Health, where we will hear 3 paper presentations on practical AI and technology examples, as well as their implications in the field of health. I'm happy to welcome also our speakers for this session and would like to quickly introduce them to you. Our first speaker will be Sotiris Kousouris. He's the Managing Director of Sud5 Data Intelligence Solutions Limited. He's also a Project and R&D Innovation Manager at National Technical University of Athens, and his research areas are in the field of enterprise computing, business process management, web applications, and computing and technology policy. Today, he will speak about the FAITH project that relates to using federated learning to support patients' health monitoring with high quality and privacy-preserving AI services. Our second speaker will be Stefanos Venios. He's a project manager at Sud5 Data Intelligence Solutions and working on EU-funded R&D projects. He works on applying machine learning, artificial intelligence, big data analytics, and distributed ledger technologies in the domains such as e-health, aging, personal data, aviation, or energy management. He will give us some insights on the project OncoRelief, which is enhancing cancer patients' well-being and health status improvement following treatment using AI methods. And our third speaker will be Sebastian Krügel. He's a senior researcher at the TUM School of Governance and the Technische Hochschule in Ingolstadt. And his research interests are mainly in the field of decision-making and strategic interaction, ethics of digitization, effective whistleblowing systems, IoT, and autonomous driving. From him, we will hear about IoT solutions in occupational health, and especially a vignette-based acceptance study that they did in Germany. I am looking forward to the exciting thoughts that you will share with us, and actually don't want to steal much more of your time. So my last remark is for the participants. We are happy, and our speakers are happy to answer you any questions. So please raise your hand so that we can unmute you for further discussion, or simply write in the chat. Simply write your questions in the chat. So I'll admit further participants. And then this is it from my side. I would hand over to Sotiris, our first speaker, for his first presentation.
Okay, thank you very much, Ellen, and good morning, everyone. It's a pleasure to be on this conference, even if it's online due to the unlikely, events that we all know in Munich. I guess it would be wonderful to be there this time of the year, especially, but we'll have to do it online. So looking forward for the next years for a physical attendance. So as Ellen said, my name is Sotiris Kousouris. I work for a company called Sud5 Data Intelligence Solution that is based in Cyprus, in Limassol. And today I'm going to give a quite high-level presentation of the FAITH project, which is a European co-funded project that actually talks about how we can use federated learning to actually support patients' health and well-being after they have gone cancer treatment. So FAITH stands for Federated Artificial Intelligence Solutions for Monitoring Mental Health Status After Cancer Treatment. And as the title suggests, and Ellen also mentioned, the idea in this project is actually to build a solution that can, in a way, identify depression markers of people that have undergone a cancer treatment in order to help them improve the quality of life and notify their caregivers, whether those are clinicians or other stakeholders like family members and so on, in case, mental health is decreasing, and those people should be somehow supported in order to regain the status of quality of life they should enjoy. So the motivation behind the FAITH project is exactly that cancer is probably, the biggest medical challenge and disease in our age, and it apart from the different disabilities it brings to people, and the different problems, it also has a lot of burden when it comes to depression and mental health. So approximately 15 to 25% of the patients do suffer from depression. And as we can see that these numbers are rising because our population is aging, so the occurrence of cancer is more and more likely, and depression then becomes more and more likely. There should be a way not only to fight this disease, which is being done quite effectively in the last years through modern medicine, but also to be able to allow to cancer survivors enjoy a high quality of life, not being affected by all the consequences that this disease brings, and make them and take them, to elevated and better level of enjoying life and understanding actually how they're affected by what they do. So faith, as I already told, is targeting exactly this stage. So we are not talking about something like cancer treatment, but we are talking about supporting and helping people in the post-treatment era, so that they have been diagnosed, they have been cured, and now they should be also treated for any leftovers. And the idea is actually to use artificial intelligence and similar technologies in order to track down such depression markers that there could be, identify trajectories, and make them make the patients and their caregivers aware of such growing situations in order to be able to act in a proactive manner and actually allow the patient to be back on track where he should be in this post-treatment path. However, as we're talking here about AI and health, I have to actually state that the overall idea of this project, of the FAITH project, is not to build a medical device. So we are building a solution that actually supports people and can be seen as a health application, but it's not a medical device. And this is due to many reasons. Many of them have to do with getting the proper certifications to be able to be categorized as a medical device, then running through ethics committees and so on, things that take a lot of time, a lot of effort, and are actually and need actually to be tested on a long track, which we don't have, in such a small project as FAITH. So how is this working? So the overall idea of the FAITH project is that there is an ecosystem of stakeholders with a patient being in the center of it, that is actually caring about the patient and is actually working based on data and information that are provided by the patient. So we have the patient that provides information through an IT solution and application, as we will see in the next slides. And all this data is then analyzed and forwarded to different other stakeholders, like healthcare professionals, nurses, and doctors, and anybody that is relevant with who is responsible for the condition of such a patient, as well as data scientists, which are actually working with the data to analyze them prior to serving those to the medical personnel, working on an approach that has at its core a federated learning AI mechanism, as we will see in a while. So actually, the idea is that when a patient, after the treatment, leaves the hospital, he actually receives two things. The one is a mobile application that he can install in his device, and the other is a tracker device, which is a normal activity tracker. We are not talking here about something that is custom made, but we're talking about normal wearable devices that can measure things like sleep and activity. Think about all the bands that somebody can have, like an Apple Watch, a Fitbit band, a Garmin watch, or whatever. And through those two, let's say, devices, or those two things, the application and the tracker, things are actually recorded, are recorded. On the one side, we have things that are recorded passively, so without the user providing any data, but automatically pulling data out of the devices. This can be for sleep tracking or for activity tracking, how much has somebody walked or what types of exercises and physical activity he has done during the day, as well as interactive information that is collected actually through the app. Information about appetite, because we're talking also about nutrition and appetite that plays a huge role when it comes to depression, and outlook information like asking the patient how he feels today, and some general questions that can actually evaluate his actual degree of well-being. All those information are also coupled with questionnaires, and eventually what we have is the clinical assessment of each patient, which is done based on the analysis that we have for this information. So this is what is being done, and information is collected. In case there is a negative forecast, the idea is actually to trigger some alerts, and those are sent to the healthcare providers or the caregivers of that exact patient, who in turn analyze those and can offer the proper support. So in all this flow, of course, AI and machine learning is quite important, and everything can be done, of course, using a centralized intelligence engine, where all this information that is collected from the mobile device and the questionnaires are offloaded on a cloud-based server or whatever you think, and the processing can happen there, and the results can be provided. However, we feel that when we're talking about medical data, and when we're talking about such sensitive data, it is actually best to follow a more privacy-preserving methodology and way of working, which can be offered by federated learning. So in such a case, what we have is that we don't have data being offloaded from the user's device to a cloud server, but we have everything running locally using AI models that can run on the device, so that data actually stays locally. Models are actually downloaded, let's say, from a cloud server to the device. All the analysis is happening on the device, and only the data are sent back to the cloud server in order actually to trim the model. So this approach, which is based on TensorFlow Lite technology, which is what we're using in the project, is able actually to offer a very high degree of privacy to the users, allows the user to trust better what is happening with the data, because none of this data is leaving actually their device. And we can also talk about having more personalized AI models. So essentially, all the intelligence, all the operations are being performed in the device of the user. All the data that is collected there is not leaving the device. And the only occurrence when this can happen is when a negative trend is forecasted, and then the user is explicitly giving consent to a doctor to download the collected information to have a look at it. Otherwise, we're talking about a fully privacy-preserving solution here, where AI is actually serving its needs and don't mess up with things like ethics, with things like data protection, and all the relevant issues that are actually hindering its adoption in more centralized and cloud-based environments. So in the project, we're going to test all those assumptions we have on all the technology that we're building in 3 different hospitals for 1 year of trials. We have partners from Portugal, from Spain, and from Ireland, actually hospitals that do have oncology clinics. And this is where we're going to focus, mostly dealing with breast and lung cancer survivors. And this is where we're going to test all the different algorithms that we're building. So essentially what we are working here is to provide a full, let's say, system that has at its core an AI solution that is actually developed to identify and analyze those depression markers, which is validated in the different settings, and it actually allows to increase the awareness of both the patients and of their caregivers about the mental health of those stakeholders. Of course, in our approach, there are many challenges that we need to overcome. And this is actually work in progress because the project is fairly new. We're just in the 2nd year. We are building the technology. We're not there yet in the trial environment. So most of them have been identified and are being dealt with, but it's not over yet. So talking about the challenges, the first one is to identify the right indicator. So what should we measure and how should we measure it? What is the most cost-effective manner to collect data, and the one that is non-intrusive, because you can think that this is a very sensitive group and you should not actually get this group doing the work for you. And of course, how we can filter out noise and non-accurate data. One path that we're on here is actually utilizing, as we said, smart bands and wearable information that come from known vendors who actually perform some of these tasks for us, like filtering the data, correcting and cleaning the data, and we just take the data out of the different hubs, let's say information hubs that are available in devices like Apple Health Kit or Google Fit, where data are more or less optimized. Another challenge has to do with the validation of the models that we're going to build. Actually, this model needs to be developed in close collaboration with data scientists, medical researchers, as well as clinicians, in order to understand the different aspects of such a model. So there is a big challenge in bringing those different worlds together. Another challenge has to do actually with how to explain the results of the AI, both to patients and also to clinicians. So people need to trust the AI outputs. We need to provide them evidence that the results are correct. And we need to also find smart ways to interpret these results in order for them to be understandable by the different stakeholders. Of course, by utilizing different ways and different manners of explaining this. Those could be, I don't know, complex graphs for clinicians, but could be just plain narratives or sentences for patients. But there needs to be, quite a lot of work in order to be able to convey the correct messages in the correct manner to those stakeholder groups. And of course, there are other issues, things that have to do with privacy. So we talk about federated learning, but we need to see how complex models we can support on mobile devices, what those entail when it comes to processing, power and battery life that we need, what we should do with past data. Should we, get rid of them if the storage gets full or what? And also other challenges that have to do with how to support the different clinicians, how to motivate them to utilize the app and not see the app as, an enemy that wants to take over their job. This is not the case, but we have to persuade clinicians to embrace and adopt a new way of working, and of course how to engage the users. So how to make the system more appealing, how to make them, as I said, trust the system, how to motivate them to follow the recommendations, and how to make them actually utilize the system daily. And this is partly done by collecting automatically the information out of the wearables, and also by employing technologies that have to do with NLP, and having the application actually talking to the user to get some oral feedback that can be analyzed not only towards the content of the feedback, so what the user has said, but also understanding the tones and the difference in the voice of the user, pointing also to some indications whether this user is depressed and so on, by analyzing the tone of his voice within the day. So all this is about the FAITH project. Is as I said, a quite and fairly new project. We are at the moment developing our technology. We are in the first steps of developing our AI engine. So I guess next year we will have much more things to present there from the AI perspective. But I invite everybody to join the different social media groups to find out more about FAITH, and of course join the website that you see in this slide to learn more and get in touch with us. So that would be all from me. Thank you very much. I will be happy to take any questions.
Thank you very much for this really interesting insights into your project. I think this is a really important project, especially for me, since I recently worked on exactly this problem of how to solve individuality and data privacy balance. And I think it's really interesting that you found a solution how to make it more individualized, but still have data privacy in place. I see we don't have any questions on the chat, so I just have one question for you. Did you have the chance to talk to the clinicians or patients that would use such an applications already? And did you see also what they think about how they think this approach, especially when it comes to mental health and including more family members? Did you have the chance to talk to them what their perceptions are?
Yeah, at this point, we did not talk to patients, but we talked to clinicians because they are key in our project. Actually, they were quite, let's say, thrilled about such a project, because the way that you work right now is with standardized questionnaires that they mail or they retrieve from patients in the regular meetings that they have, let's say once a month or so, when people come back to the clinic to just do a checkup and so on. So they're thrilled because they feel that such an approach, using also mobile devices, so things that people are familiar with, and a constant tracking of some metrics, allows them to quite easily and faster identify trajectories, or whether somebody is not feeling well in terms of depression and stuff like that, which cannot be measured that accurately by filling in questionnaires once every month and having some talks. Because the day you're gonna fill in the questionnaire, you might be quite happy, but you might be 2 weeks previously you would be in a very bad mood. So this is something that they're very thrilled to use. Of course, we have to see the final results. The other plus point is that they actually like very much the idea of having this federated learning approach, because this actually frees their hand from one side that has to do with ethics and bringing all this information within the system of the hospital and the clinic, because they have to do through ethic committees and get the permission to use such data and so on. But having a federated learning approach actually makes things much more easier. Of course, there are ethical agreements to be made, but much more simpler. and the fact that at the end they don't hold their data on their hands, so on their premises and so on, is something that is, not only putting burden on them, but also allow them to focus on the core of their business rather than, invest money on things like data protection, ethics management, and stuff like that.
Yeah, it fits great into the idea of responsible AI. Okay, thank you. Thank you, Sotiris. I would like to hand over to our second speaker now, Stefanos. So please share your screen and we're happy to hear your presentation.
Yes, hello, also from me. This is Stefanos Venios of Suite 5 Data Intelligence Solutions. I'm also disappointed that we're not able to meet in person, and also lost the opportunity of a nice trip to Munich. So this paper that I will present today is the result of the first half of the work in project OncoRelief. This project has received funding from the European Union in the context of Horizon 2020 framework. And as you have already prepared as you have already said to the attendees, it uses AI methods to enhance the well-being of cancer survivors and to improve their health status post-treatment. The goal of OncoRelief as a project is to improve the post-treatment health status, well-being, and follow-up care for cancer patients in order to meet their needs and allow for timely suggestions. We will explain what we mean by the very general term, meet their needs, before these patients face increased therapeutic side effects, emotional distress, or any kind of biobehavioral factors promoting cancer progression. The high-level objectives of the project are to analyze everything, clinical settings, parameters, environmental dynamics, and drive forces of the well-being of cancer patients and model them as indices. To exploit big data in order to generate what we call holistic post-treatment insights. So here you use big data to generate insights, as you usually do with this kind of large volumes of data. To develop innovative technological elements, so to build software in a sense, in order to provide personalized well-being. Then to validate all these assumptions in different cancer types so that we don't only concentrate in one cancer type and different patient environment settings, so we don't concentrate only on one case, and to actually measure the impacts of all this work in pilot hospital premises. OncoRelief, in principle, and we start from the right-hand side of the slide, aims to deliver a mobile application. It's called the OncoRelief Guardian Angel, at least it's called like that in the context of the project that we're running now, which will extract insights about the life of the patient and the condition, and will make suggestions for their well-being. The app, in order to do so, will be connected with sensing devices, with wearable devices, and with the OncoRelief backend data collection platform, and will use AI models produced by the OncoRelief AI engine, in order, which the AI engine is used to produce the indices, recommendation, and warnings. So as you see, there is a kind of a loop. The AI engine uses data and produces algorithms which are then simplified and sent to the mobile app, and the mobile app may optionally send data back to the AI engine in order to close the loop and improve the analytics models. To have the data that we can feed to the AI engine, we also need a backend platform, which will collect the data from the heterogeneous sources, anonymize, annotate, transform them, and store them. The data sources that we use in this project are divided into dynamic data and static data. On the one hand, we have the measurements from the wearable sensors. And on the other hand, we have direct input that we collect from the patients in the form of replies to standard medical questionnaires and data coming, personal and medical data coming from the medical record of each patient kept at the hospital. So we have created a data model taking these data sources into account. In order to foster future interoperability, we have adapted the FHIR standard. It's a standard from HL7, Health Level 7, an organization that is standardizing the way we store and exchange e-health data. So we transform all the data that we collect in the FHIR format before storing to the backend storage, so that, as I said, with the interoperability in mind. The source for collecting the data will be a number of about 300 different patients, which are on follow-up from 2 different types of cancer, colorectal cancer and acute myeloid leukemia, across 2 hospitals in Germany and Italy, as we will see further on. Here, this could be a boring or confusing slide. It's an overview of the architecture. On the left-hand side, you have the patient device ecosystem. You can see there the mobile app, the Guardian Angel app, and the sensing framework, which are wearable sensors. On the right side, you can see the high-level design of the OncoRelief platform, that it includes the backend functionality to manipulate the data, to manage the data, the database itself, the health status prediction analysis component, and the AI engine, which employs the machine learning algorithm and the medical imaging analysis. Now, having seen a bit what is the aspiration of the project, we can check closer a couple of indices that we calculate and estimate in this project. So the primary index is called the Quality of Life Index. This is coming from research in the context of the project from hospital partners, and it is a measure of the balance of met and unmet biopsychosocial needs of cancer survivors. This is based on the scores of the questionnaires and other assessment tools, which measure each of the specific needs and convert all this data to a 0 to 1,000 score. So we have identified certain needs that are related to each cancer type, and we assign scores to each of those certain needs coming from questionnaires. So since you have the needs, or you think you have the needs, you can find questionnaires to calculate score for those needs, and then you can use those scores to calculate a higher, more generic index that is called the quality of life. Higher index scores indicate that the patients tend to have more met needs than unmet needs, and lower index scores indicate the opposite. We have on the bottom left of the slide a very first gradation of the quality of life index. That is let's say, living research going along with the project, and I cannot say that it's something that is finalized yet. The category indices are based on the weighted average of the indicator scores in the category. There are different weights for each indicator. So if you look at the tables on the right, there are some categories per type of cancer and some needs which make up each category. We are going to assign different weights at each indicator, but in order to define this, we will need to go through the evaluation phase in the pilots and use the analytics to help us in this direction and to help us experiment with various models and identify which are the most fitting factors that can produce the most accurate results. As we saw in the previous slide, the quality of life index is based on the ratings of a certain number of needs like anxiety and depression. And these are grouped into need categories as distress. And each category has a rating on a scale of 0 to 1000. And the overall quality of life index is the simple average of the category indices. Pretty much this is what is seen in this slide. As I have said, we have started with what we call the baseline QOL calculation, which is being implemented currently based on questionnaire data only, and all of the weights are equally spread, but we aspire to include also the vital signals coming from the wearable, the continuous stream of vital signals coming on the wearable, and also assign different weights to each index as the project progresses. Here, since you can calculate the quality of life, here it's a good use of AI, and I have also architectures for those who are interested in it. It's how we intend to predict also the quality of life. So have an idea of what is going to happen according to the trajectory of each patient. In this project, we propose two architectures that will be tested with real data. First, you have an architecture based on recurrent neural networks that is specifically designed for the clinical domain, combining static and dynamic information in order to predict future events. In this architecture, the training data, as you can see on the top right image on the left part, the training data consists of vectors that include information for every specific patient. The first sub-vector contains the static data from questionnaires and patient medical records, and as well as the dynamic data from the sensors. In this scheme, apart from the internal structure of the neural network, the parameter T has to be defined. In other words, the number of previous steps in the time series that will be used for regression. Now, the second example, the second proposal is the ensemble learning technique. In literature, generative models such as LSTM neural networks have been used to extract temporal information from dynamic data. Then, this information can be combined with the static features in order to improve their classification performance. The architecture depicted on the second figure in the bottom right is inspired by these ideas. The static data are used to train a model that is most appropriate for this kind of data, such as an MLP or a random forest. On the other hand, the dynamic data are used to train a deep neural network architecture, specifically in this example, an LSTM network, which is suitable for time series data. The performance of both types of models are measured with metrics such as the mean square error. And in order to produce the overall prediction of the quality of life index, you combine the outputs of these two types of models as the input to a simpler model architecture, which is in the example a shallow MLP or a random forest. In this slide, I will go really fast because it wants to show that the training process includes roughly the following steps. You do the training from scratch using an initial training set from the collected data. After you have collected a sufficient amount of new data for example, after a month of collecting data. Or if you see that the prediction error goes over a predefined threshold, the machine learning model is retrained in the backend, modifies the previously trained model using the new data, and after that, it is retrained and fine-tuned and deployed again as a light version in the mobile app. Another index, further than the quality of life index that you calculate in this project, it's calculated through the wearable sensors, and it is the heart rate variability. It appears to be a significant relationship between the autonomic nervous system and cardiovascular mortality, including sudden cardiac death. Heart rate variability in particular represents one of the most promising markers, and since it is a measurement easy to derive, the HRV has become popular in recent years through the use of smart wearables. In rough lines, you could calculate the HRV by employing smart wearable devices worn on your wrist to generate what we call a PPG, photoplethysmography, that detects blood volume changes in the microvascular bed of tissue and making it possible to monitor the cardiac cycle. You cleanse this data, you detect the peaks, and then you calculate what we call the IBI interbeat intervals. The result of such a process is a calculated HRV with 46 parameters, much more than usually produced when using classic medical techniques. So once you have the calculated HRV, ideas that we want to explore in this project is to try to estimate stress levels and assess sleep quality. As you see, you can use features of the PPG bells to see and to assign them and to consider them indicative of mental stress on the one hand, and on the other hand, you can use convolutional neural networks to classify the sleep stages. In an example architecture, two deep neural networks work in the backend. The one estimates the 4 sleep stages, which is awake, light, deep, and REM sleep. And the second estimates whether the person is asleep or not. This kind of estimations, we will try to research in the second part of the project. So, as you saw, we have identified some indices or defined them, and then we try using them to feed them in machine learning and deep learning algorithms, and have as output estimations that will help us foresee what can happen to a certain patient based on his situation and his trajectory. Having the predictions as described beforehand, we can use them to construct what we call a suggestions planning framework, which is a combination of the predefined suggestions with the results from the analytics, from the AI engine as information input. So you use the analytic results as quality indicators to ensure that there is relevance for a specific patient case and for the suggestion that you propose to this patient. Of course, you cannot do this automatically. No one would allow it with the current ethical and medical standards. So the system uses, there is a UI of an interactive decision support system that fires suggestion to the physician of the person, and then it's up to the physician to select which suggestion will actually end up applying to this patient. Then the system computes the condition logic, transfers the selected suggestion to the Guardian Angel app, to the mobile app, and displays this in the UI. You can use the app to obtain feedback and close the loop by sending this feedback back to the AI engine to use it as a further input that will fine-tune, that will further, I'm so sorry, that will further help you to fine-tune if this suggestion went well for a specific cohort of patients. In order, since this is an R&D project and it's funded with union money, it needs to be validated in real world settings. So we have 2 pilot hospitals, one in Mainz in Germany, and the other is the IRST in Italy. They focus on colorectal cancer and AML respectively. During the pilot executions, they will recruit patients, give them to sign informed consent, and then allow them to use the Guardian Angel application and the wearable in order to collect directly data from them. In this way, we will have what we call the patient-reported outcomes and patient-reported experience measures, things that are very helpful when you want to validate the work at such an experimental level. With this, I will thank you for your attention. I'm happy to take any questions. This was Stefanos Venios of Suite 5.
Thank you very much for your very interesting presentation. I think it was great to see how you integrated the mental health and quality of life from a mathematical point of view. So that was very interesting for me. Given the time, I would like to shift the question and discussions to after our third speaker, if that's fine for you, and would like to immediately hand over to Sebastian Krügel, who is our third speaker of the day or of this session.
Thank you very much. Okay, I guess you can see my slides and you can hear me.
Yes.
Cool. Yeah, thanks for presenting my work today here. It's a project together with Matthias Buhl, who is also in the audience, I'm sorry. And the project is about health management in companies and how digital technologies and probably AI can be used to increase employee health and reduce the number of sick days. And today, occupational health makes little use of digital technologies, and this is the starting point of this project. The idea is to support employee health by connecting smart devices, and that's why it's IoT, Internet of Things, and to build assistant systems, and that's why IoT assists. The project is funded by the German Ministry of Finance and then of Education and Research. Sorry. The project involves a group of partners, the German Institute for Artificial Intelligence, but also universities and colleges, and industry partners such as software companies and hardware companies. One important use case in the project is back pain. And back pain is, of course, a big problem. In Germany, for instance, roughly 3/4 of employees experience back pain at least once a year. And in 2017, for instance, there were almost 60 million days of sick leave due to the diagnosis of back pain alone. On average, this makes roughly 164,000 employees that were absent from work in German companies in 2017. And one reason mainly is that we just sit too much. We move more or less only from one sitting position to another one, and we often sit incorrectly and so on and so forth. And here the idea is that occupational health management may help to reduce the number of sick days and foster the health of employees in the long term with the use of smart devices. And the goal of the project is actually to develop some devices ourselves and a platform, which I will talk about a little bit later on. And some devices are, for instance, smart cushions or a smart chair that measures the sitting duration or sitting position of the employees, but also smart suspenders that measures whether people or whether employees lift heavy things correctly. And so, other devices might be a smart bottle in the future, or a smart jar that measures calorie intake, or whether people drink enough and maybe remind people that they should drink some water or something. Yeah? So, but this is only one part of the project, is to develop some devices. Another important part is actually to bring these devices together on a platform and to easily add different devices of different companies, and for users to easily create workflows in an if-then logic. So let's say that the chair is connected to the desk and this is connected to the office light or something, then the user might just create a workflow that if the chair recognizes that I sit too long, let's say 30 minutes or 15 minutes or an hour, then it sends a signal to the office light and turns red and reminds me to walk or to move the standing desk up or something. And when it comes to these systems, it's of course important to know about the acceptance of employees, of the potential users, and their usage, and the usage of these systems. And when it comes to the usage of these systems, this is something that we plan to do the next year, because it's important to see whether actually these systems are used in the first place and whether they indeed can change behavior. Right now our project partners are developing what they call a workshop box, and so they try to produce these devices, which I've shown you a little bit 2 or 3 slides earlier, and then to include these in the workshop box, and so that we can go with this workshop box to companies and then actually try to see whether employees use these devices and whether it helps to work healthier, whether it has a behavioral impact. But it's also important to measure the level of acceptance and potential concerns of the potential users early on. That's also in line with the idea of an ethically aligned design, that already in the design phase you address potential concerns of employees. And when it comes to human-centered design, so it's important. So this is what I actually would like to talk here, which I would like to present here. It was a survey where we tried to measure the acceptance of potential systems, assistance systems. So with the help of the survey, we tried to measure the acceptance or concerns of employees regarding the use of these systems, and we more or less conducted a German-wide representative survey with almost 1,600 participants in the working age, so between 18 and 65 years. It was a vignette-based study where we used different scenarios targeting back pain prevention. So a vignette-based study is something that you present the participants a scenario and you ask questions about the scenario. And the basic scenario in our study was something where a company introduced standing desks and office chairs that are connected with each other. And then we get different manipulations actually, and we asked the participants whether they would like something like this in order to prevent back pain or to reduce back pain, and what their concerns would be. And we more or less, or mainly used 7 points. So we presented statements, and they could agree or disagree with these statements on a 7-point Likert scale. So I don't want to go into too much detail here, since I only have 5 minutes left, but we have we used different treatments where we manipulated the scenarios a little bit. So in some scenarios, there was a subtle message that if the office chair recognized that you sit too long, that it sends a message to your laptop, and the laptop then tells you that you should probably move the standing desk. This was a subtle message, or a more marked message where actually the laptop, the office chair was connected to the desk, and the desk then changed color once you were sitting for too long, and reminding you that you should move the desk up, or the desk even moved up automatically. And we placed this measure in the scenarios, either in a 4-person office in a company, a single office, or the home office. And as much as I can say to these different scenarios or these different treatments, there was some variation, but it was actually not very substantial and not really significant. So we see, for instance, that women appear to like the marked message more than min, and min appear to like the subtle message more, and that people feel more watched and more observed by their colleagues in a 4-person office than in a single office. So there is some variation. It makes a lot of sense, but all in all, there was not much variation between these treatments, and we put all the data together. And what we see actually, so what you see here, those are the average scores to these statements. And if it's a positive statement, so 0 means they disagree with the statement, 6 means they strongly agree with the statement, 3 saying that they are neutral towards the statement. And if it's a positive statement and they agree with the statement, so they signal a positive attitude towards the measure. And if it's a negative statement and they disagree with the negative statement, then this concern is not really relevant for them. So what we see actually is that people, when it comes to questions regarding the acceptance of this, whether they like the measure, whether they would like that the company introduces such a measure or something like this, we see a very positive attitude towards such systems. And we also see that people expect that it's just their statements, but still they expect that it would impact their behavior, it would help them to prevent back pain, to reduce back pain, to stay more often, to stand more often, to walk more, and so on and so forth. And it was a bit surprising that actually they didn't really have any concerns about the measure. They were not concerned whether that the company might control them, or that the employees could monitor their behavior, or that they would feel restricted in their autonomy, and not even when it comes to data collection. They just don't worry about it. Data collection was the greatest concern, but on a very, very low level. But what we also see, so they like these measures, they don't have any concerns about it, but they wouldn't like to pay for it. So they expect that the company pays for it. And just quickly some other results. So we don't see any difference between men and women, no substantial differences. What is important is the attitude towards health, not so much the actual health behavior when it comes to the liking of these measures. What is important is the enthusiasm for technology, not so much the actual knowledge of technology. So that's from a company's perspective, from an occupational health management perspective, that's good to know. So you don't need, let's say, computer scientists that they are willing to use these measures. And you don't need people who are actually already living quite healthy. Then you don't need these measures anymore. So you try to increase the attitude and enthusiasm for the technology, and then they might be willing to accept these measures. And the last point might be an important one, that what we also found is that the less the study participants themselves suffered from back pain, the less they approved of the health measure, and the less willing they were to subsidize them. So this signals what is often called an empathy gap. It's actually a typical finding in the psychological and behavioral economics literature, that people have problems to put themselves in the shoes of themselves in another situation. And this might be a problem, especially when it comes to prevention of back pain. So if, because most of these measures actually are supposed to be used as a prevention measure, and but people might not be willing to use these measures. They might be willing to use these measures only when it's too late, when they already have back pain. So this is something that you have to address probably. So to quickly summarize, so in occupational health management, there is a tremendous but as yet untapped potential for IoT solutions that may enable the interoperability between devices and services and playfully support the achievement of individual health goals. Gamification is here a buzzword. Our computer scientists in the project, they appear to have strong faith in gamification elements, and as a behavioral economist, I'm a bit more skeptical about it, but this is something that we would like to see in the next year, when we actually have a workshop box, and then can go to companies and see whether actually these gamification elements, such that employees can earn points if they, I don't know, work more in standing position or something like this, that they actually indeed do this, and these gamification elements helps them. This is something that we are very interested in the upcoming year to see. Our study in general shows that employees find these solutions desirable and promising, and they have hardly any concerns about it, not even when it comes to data collection. Yeah? Especially this was when within a company, or when it comes to the health domain, you would think that people are concerned about data collection, but this is not what our participants stated, at least. Yeah? But they are not willing to subsidize these measures with their own money. Yeah? And lastly, beware of possible empathy gaps, yeah, if you ask the wrong people in your own acceptance study. So it's a little bit over time, but so this was what I wanted to tell you. Thank you.
Thank you very much for this presentation. I don't know how the other audience felt, but I immediately tried to sit in a more upright position when I heard that. So maybe that could also be a key takeaway message, to have more such presentations. We don't have any questions in the chat. I just have one, let's say, short question. Do you think, because you said that the attitude towards health also impacts whether people are more open for such systems and such technologies, do you think one message could also be for businesses to apply that in practice, to more work on the attitudes of towards health of their employees? Do you think this could also be one key approach?
Yeah, no, sure. I mean, the point that appears to be important to me is that it's not so important. It would be much more difficult, I think, if it would be necessary, or if people would be only willing to use these systems if they live healthy anyways, or if they have a very high knowledge and regarding technology. This would be much more difficult actually to have these systems used or accepted among employees. So I think it's much more easier if it's just about the attitude towards living health. So I would like to live healthier, please help me, something like this. I like technology and I'm curious about it. So this is something I think from a company's perspective is much more easier actually to work on. You don't need to have a certain group of people working in a company. Just try to improve the attitude to make them aware of back pain and prevention of back pain, and that technology might help them to reach these goals.
Yeah, especially since it's a very important problem, as you said. Mm-hmm. Okay, thank you very much. Also, given the time, I would like to wrap up this session, and thank you for your participation and the interesting presentations we've heard today. Already now we have on the main stage our spotlight chat on innovative AI to reach the needs of vulnerable culture. So I would like to invite you to now join with me to the main stage, and I hope to see you in many more sessions today and tomorrow, and hope you enjoy this conference and hope to see you soon.